All right. Hope everybody had a good 3-day weekend. We are now 5 weeks from the end of the school year.
I am
So,
ready to be out of this place.
really?
Yeah. Like, you're pretty chill, but, like, I hate, like, the rest of everybody.
Oh, I'm glad I'm on the good side of that. So, okay. What's that, David?
I said most of everybody.
You saw a horse in somebody's backyard? Hey, nice. Okay.
I had to wear.
You know, the thing about horses, I never know why they have a long face because they come from a stable home. He didn't hear me.
That was a good joke.
That was a good joke. Okay. All right. So we are starting our new unit today. We're going to go ahead and start talking about sequences and then ultimately series, both arithmetic and geometric. But before we go ahead and do so, class average was 96.6. Okay. So you guys had a very high class average. You did really well. Was there anything about the test we wanted to talk about? Start with complicated problems like what? Oh. Yes, sir. Do that very last one? Okay. Let's talk about that one because I believe that is really the only one people missed any points on. This last one right here. Okay. So it says a boat with direction 140 degrees with a speed of 28 miles per hour is traveling in a current with a speed of 8 miles per hour at a direction of 230 degrees. What is the actual speed and direction of the boat? Round your answer to the nearest hundredth. Okay. So we have a boat. We also have the speed of the river, the current that we're looking at. So what we want to do is go ahead and find the component form for each of these, and then we add them up because that's going to give me the resultant. Okay, what's actually happening. So let's go ahead and say B represents the boat, and then I'll go ahead and say that C represents the current. So my resultant R is going to be just to add the two. So we're going to go ahead and say that this is from the horizontal. Okay, it does start rotating from the positive x-axis. So you remember that formula, we're going to take the magnitude times what? What's the trig? Cosine theta, comma, magnitude, sine theta. We're going to do the same thing for both the boat and the current. Okay, so it says the boat's going in the direction of 140 degrees with a speed of 28 miles per hour. So that would be 28 cosine 140, and then 28 sine of 140. Okay. And then we'll go ahead and figure out what the decimal value is in just a second. And then I can do the same thing for the current because it's going 8 miles per hour with a direction of 230 degrees. So I can say 8 cosine 230, 8 sine of 230. Okay. Now, what I want to do is go ahead and just add these together to figure out what my resultant's going to be. So how do we add and subtract vectors? Yeah, just the corresponding values.
Yeah.
So I would take 28 cosine 140 and add it to 8 cosine 230. Okay, so 28 cosine of 140. Let's see what that is. So 28 cosine of 140. Okay, let's get out of there. Then I'm going to say plus. It was 8 cosine, what was it, 230? Okay. So negative 26.59, let's say. Probably even say, 0.6. Negative 26.59. Negative 26.59. Okay. And then we'll do the same thing. We'll go ahead and add the B's. 28 sine of 140, 8 sine of 230. I'm going to come back over here. So 28 sine of 140. Okay, let's get out of this one. Plus, what was it, 8 sine of 230. Okay. So 11.87. Okay. Going down. So 11.87. And see, that would match with what we know because the boat's going in the direction of 140 degrees, which is in the second quadrant. So it makes sense, that my resultant would be in the second quadrant as well. So this is what I'm going to use to help me find the magnitude and the direction. How do I find the magnitude? There you go. Remember, this is A, this is B, so this is going to be the square root of a squared plus b squared. So let's see. Let's come on back over here. So square root, parentheses, negative 26.59 squared plus the other one, 11.87. Okay. Squared. Okay. And I think, did I say to the nearest tenth? Or what did I say on that? Nearest hundredth? Round your answer to the nearest hundredth. That is correct. So I would say 29.12. Okay. 29.12. So the boat was going 28 miles per hour, but with the current, it was actually going 29.12 miles per hour. Okay. Yeah, because if it, if the decimal was off a little bit, I still went ahead and counted it. Mm-hmm. And it depended on how much it was off, because I think some people gave me some that were pretty far off 29. Okay. It's okay. It's okay. All right. But now the direction, this is what was stumping a lot of people that day. Remember, there were some really good conversations about it. So I want to take tangent of theta is equal to b divided by a. So I'm going to take 11.87 divided by the negative 26.59. So we have to take the inverse tangent, right? But there's something about this inverse that we had to remember. So if I come back over here, let's go ahead and figure out what that is first. Tangent inverse. Oops, I don't need this. There we go. Let's see, it was 11.87. We're going to divide this by the negative 26.59. Okay. Oh, negative. Okay. There we go. So enter. Now it does give me a negative degree, right? Okay. So negative 24.06, let's say. Okay. Now here's the thing about this problem. If I were to, I'm not going to use that grid up there. Let me go ahead and draw one because that one's a little off screen. So what was it, negative 24.06? So that's going to put me in the fourth quadrant. So let's say this right here is the negative 24.06 degrees. Okay. But you have to think, what quadrant was the boat in? It was in the second because 140, right? So I need an angle that's going to get me into the second quadrant. So what you can do, remember, the reason we got this was because tangent inverse is only restricted to quadrants 1 and 4. So if I need to go into quadrant 2, I'm going to go ahead and extend this guy through so that this is 24.06 degrees. Remember, the negative just tells you the direction that you're going to rotate. So those are vertical angles. So what I need to know is how far we've rotated so that I have an angle of 24.06 left over. Okay. Or 180 minus 24. There we go. So 180 minus 24.06. So we'd be looking at about 155.94 degrees. That's the answer. That's it. That's the angle measure. 155.94. I think probably even say, 156. Okay, 155.94 degrees. Okay. And that kind of makes sense because if you think about it, from here, we know that it was 140 degrees, right? Well, take a look at the current. It's going 8 miles per hour, but it's at 230 degrees. Yeah. So the current vector for the water would actually be looking something like this. So that's 230. So it makes sense that it would push this vector down slightly. So see, it made that smaller angle. Larger overall when you start rotating from the positive x-axis. Okay, does anybody have any questions on that? Playoffs for what? No, sorry, I don't watch basketball. In fact, the only basketball game I've probably watched in the last 10 years was Tech just recently in the championship. Hello.
I hate to interrupt.
No problem.
Do you have Harris here?
Marcus Harris?
Mm-hmm.
Yes.
And him, let's see who else.
And who else?
Harris, that's him.
Mm-hmm.
Lopez, do you have her?
Deborah. Okay.
And
Who else do we need?
Martinez.
Antonio.
Antonio.
Okay.
Nothing.
That's it? Okay. She can
Her,
just
her mix.
speak to you three folks out in the hallway for a second. Okay. So after going over the tests, like I said, you guys did a great job. This was the only, problem I think really had some people losing points. Okay. Well, you're the only academic class that I have. Well, but out of all my pre-cal classes, whether it's IS or academic, you guys had the highest. See, the highest I got for a pre-cal IS class on their test was 85.5. 76 was second period, yes. Now that is math studies, though. They had a test over differential calculus.
What is math studies like?
Math studies is I kind of like to describe it as a buffet because you get a lot of different topics, but there's really no depth to it. It's basically just introducing you to the idea without going into a lot of the derivation, a lot of the details. Okay, so we do a unit on statistics, we have a trig unit, we have a calculus unit, geometry, algebra, just a whole wide range of different concepts. Okay, and Kiana, you used to be in IB. Well, are you still in IB? Because I know you got out of my math studies class. So you're not in IB anymore? Okay, but if you want to know, she was in the class for at least into this semester. I think it was, yeah. Mm-hmm. It's a good class. It was fun, right? Hey, well, you're doing really good. You're doing really good. Okay. So good. All right. Were you pointing at me or him? Oh, okay. Well, he got really quiet, and Lex says, "Do you want to know who's fake?" And she just points. Okay. All right. I like to think I represent, but who knows?
You're fake.
What does that mean? Oh,
No.
he seems like a genuine friend.
It's kind of like imaginary. Like, imaginary.
Yeah.
Yeah.
Same idea. Yeah, there you go. There you go. All right. Well, we are starting sequences and series this week. We're going to go ahead and break it up. This first lesson is just over arithmetic and geometric sequences. So basically, we're all looking at patterns. Okay, we're either going to be adding the same number over and over and over again to generate a sequence, or we're going to be multiplying by the same value over and over again to generate a sequence. So I'm going to give you a little bit of time to go ahead and copy those down. Got some examples over here for you. And then we'll go ahead and just start talking about them. I think today will most likely be just the vocabulary, a little bit of introduction, and we'll really start getting into the problems tomorrow. What do you mean? Oh, out of these 5? I definitely prefer the explicit.
Is that like
Because those formulas are much, much easier to work with. I think you were back in IS when we were doing this, or no? Think so? Okay. Oh, one more thing. The recursive is typically not one people like to go ahead and use when dealing with sequences. Finite. 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 So we have infinite and finite. Not Fortnite, no. Something different. I'm sorry?
Yeah, because if that's finite.
Oh, well, I guess it could be like tomato. I always say finite. Finesse? Even though there's no S? All right. So a sequence is an ordered progression of numbers. So it's either arithmetic or geometric. So a finite sequence has a certain number of terms. A infinite sequence goes on forever. So if you're looking at my examples here, how can you tell if it's going to be finite or infinite? What's a little notation? There you go. If you see ... that means whatever pattern you notice is going to continue forever. If there's no ... it just stops right there at that last term. In a manner of speaking, like I can show you some, they can be referred to as telescoping graphs. You'll probably see something that... looks like that, or something that starts large and starts to get small.
So wait, okay, say they're on like a number, I don't know what they're called anymore. We used to do it in elementary. Where like it's like that. Yeah, number line. So it's
Uh-huh.
like number line. Those keep on going, but the finite would stop.
Yes. So here, it's not that we're looking at just numbers on a number line. We're looking at a pattern that generates those numbers. So something that give me, yes. Like in this one right here, how do I get from a 2 to a 7?
Plus 5.
And what's 7 plus 5?
12.
Plus 5.
17.
And so you could easily keep that pattern going. That's what we're going to be looking at. Okay. Now, there's two types of formulas that we're going to be looking at in this unit, a recursive formula and an explicit formula. Now, in a recursive rule, each term makes reference to a previous term. In an explicit rule, makes reference to a first term. Okay, so here's the thing about recursive and explicit. The one we're definitely going to want to use is the explicit formula. That will provide you any term that you want in a sequence. Like let's say, for example, I've got a sequence that's been generated and I want to know what the 50th term is. Well, if I have the explicit formula, I can immediately just plug in the term number that I want to find, and it will simplify and find me that term. But with recursive, those are always based on knowing the previous term. So if I want to know the 50th term, I have to know the 49th. But in order to know the 49th, I need the 48th. So basically, in a recursive, if I want the 50th term, I have to start with the very first one and go all the way to the term that I'm looking for. So if it's something small, if you're wanting something like maybe the 5th or 10th term, recursive formulas are really good in that respect. But if you're wanting like the 100th or the 200th term, explicit is the way you're going to want to go, because you don't want to sit there, all day and go ahead and just list these out. Okay, so with recursive, though, there's always a couple things you have to give. You need to go ahead and give the value of the first term, okay? And you need to go ahead and give a restriction. K has got to be greater than or equal to 2. Now, when we talk about these terms here, these little subscripts, they can be called different variables. I mean, they can be seen as N or K, or usually the most commonplace ones. But whatever that subscript is, that's the term number that you're looking for. So A sub 1, that's the first term. If I were to give you A sub 7, that would represent what? The 7th term. Okay, yeah. If I were to give you, A sub 10, that means the 10th term. That's exactly right. That's what the notation means. Okay. Well, let's go ahead and actually kind of work this one out to give you an idea of how a recursive works. Now, look at the formula. It says A sub k. So if I want to find the kth term, then I take A sub k minus 1 plus 5. Okay. We see how, let's say I have the first term. So the next term I would want to find is 2. I would want to find the second term. Well, in this case, A sub 2 tells me that k equals 2, right? So I'm going to take that value of k and I'm going to plug it into the formula. So A sub k is A sub 2, which is equal to A sub k minus 1. So A sub 2 minus 1 plus 5. Okay. But what is 2 minus 1? 1 plus 5. Let's see, we already know what the first term is. So I just plug in my 3 plus 5 and I get 8. Okay. See, the only way to get the second term is by knowing the previous term, the first one. So let's say I wanted to find the third term. Well, in this case, k equals what? 3. So I'm going to plug this into the formula. So A sub k minus 1 would be A sub 3 minus 1 plus 5. But what's 3 minus 1? 2. So you'll notice I've got to use the second term in order to find the third. Well, what was the second term? 8. So I would say 8 plus 5, we got 13. And see, now that pattern would continue. Okay. So see, there's also going to come a point where you can probably notice the pattern and you don't have to keep plugging in, to the formula. But the thing I want you to see here is that in order to find the second, I needed the first. In order to find the third, I needed the second. Uh-huh. Oh, no. See, here's the formula right here. So when I plugged in, I take the previous term and I add 5. So the 3 plus 5 gave me the 8. Oh, okay, I see what you mean. Because here, we know already that the first term was 3. So all I did was replace the first term with the 3. So in the second part here, I know that in order to find the third term, I need the second term, which we found to be 8, plus 5.
If you see that A1 is 3,
Uh-huh.
and you see that plus 5 after AK minus 1,
Yes.
wouldn't that basically just tell you what?
Oh yeah, this is just a way of writing a formula that's dependent on the previous term.
Say we get a problem that has A1 equals 3, and then it says like the whole AK minus 1 equals 5.
Yeah. And see, and then that's the point that I'm trying to make. You probably don't even need to substitute in anymore. It looks like in order to find the next term, what are we doing?
Just adding.
Just adding what?
5.
Adding 5. So what's 13 plus 5?
18.
So let's see. Let's go ahead and plug in one more time. Okay.
So, A1 plus 5, how does that equal 3?
A1.
Well, because we were given the first term,
Okay.
a sub 1 equals 3. And see, a sub 2, the second term turned out to be 8.
Okay.
So that's why I replaced it.
So unless
So now let's walk through this one more time. Okay. So what's the value of k here? 4. So a sub k minus 1 would be a sub 4 minus 1, and then we have the plus 5, right? Well, what's 4 minus 1? So what this is really telling me to do is take the third term and then add 5. Let's see, we just found the third term to be 13, so all I'm going to do is substitute. And what's 13 plus 5? 18.
useless if you can't just tell what the
And see, that's the point. You'll probably need a recursive formula to go ahead and get maybe the first 2 or 3 terms. But you don't have to continue substituting it in. Like Lexi said, if you notice that all you're doing is adding 5 over and over again, I would just go off the pattern and not worry about the substitution. What would the next term be? What's 18 plus 5? 23. And then it would be 28. But see, the point that I'm trying you to see is that the recursive formula, you need the previous term in order to get the most current one. Is everybody okay with that?
Yeah.
But for explicit, I don't have to do that. If I want the 10th term, I plug in 10 and it will immediately give me that. So explicit is definitely the way we want to go there. Okay. All right. And then we have a few more definitions here before we get to our first examples. Converges and diverges.
Mr. West, we should have a senior countdown. Chalkboard.
Oh, you want to do that?
Yeah.
Okay. Hey, come on in, man.
Hey. Oh yeah, you could.
Okay.
Live our best lives. When I get older, I'm gonna have one of those houses where you can walk around.
So I'm guessing you're not going to have a lot of windows or open spaces, or?
I'm gonna have nothing but.
Oh, no. Okay.
It's
Okay.
not what's it called, Zootopia, where all those animals are walking around.
My house is more like the, I think it's the Family Guy episode where they did.
Okay. Yeah, all right.
Doors are gonna be windows.
The windows are going to be windows. There you go.
I want one of those modern houses where everything's so bright and like clean.
Man, I'm gonna have a house in every state.
Wow, 50 houses.
Hey, you're gonna be there.
All right.
Reality.
Okay. So a sequence converges if the limit as n approaches infinity is a finite number, and will diverge if the limit as n approaches infinity is non-existent. So you remember those graphs that I showed just a second ago, where I referred to them as a telescoping graph? Okay. If you start out with something large and it starts to get really small, meaning if it approaches a specific number, that's what we mean when we say it converges. But diverges means you're going to start out small, and then your values are just going to start to get larger and larger. Okay, so let me go ahead and introduce these last two ideas, and then we'll come back and revisit what it means to converge and diverge. We're actually going to be using some ideas from rational functions to make some of these a little easier for us. So each term of a geometric sequence can be determined by a common ratio. Each term of an arithmetic sequence can be determined by using a common difference. So if you see common ratio, that means we're multiplying by something over and over to get the next term. We use the variable r to represent that. So r for the common ratio. In fact, if you take a look here, okay, it says 8, 4, 2, 1. So what am I multiplying each term by to get the next one?
1/2.
I'm multiplying by 1/2.
Yeah.
8 times a half,
4.
4 times a half, 2 times a half, and you'll notice it just keeps going, right? So here, the common ratio that generates that sequence would be 1/2.
Yeah.
Okay,
That's it.
that's it. Now, each term of an arithmetic sequence can be determined by using a common difference. So when you see common difference, you're talking about an arithmetic, and we use the variable d to help me out here. So look at this sequence that we have. What am I constantly adding to get the next term? Yeah, 1 plus 4 will give me 5. Plus 4 is 9. Plus 4 is 13. Plus 4 is 17, and it would continue. So here the common difference, we use the variable d, is 4. Okay. So one of these will diverge. One of these will converge. Remember, if it converges, that means you're going to be approaching a specific number. It's kind of like the sequence is getting smaller and smaller. If it diverges, that means your sequence is not approaching a specific number. That means probably your values are getting larger and larger. What would you say about the geometric one here? Would you say it converges or diverges? It converges. It is getting smaller, right? So it's going to approach a specific number. In fact, this one's going to approach 0. This one converges.
It never reaches it though, right?
It will never reach it. Mathematically, you can always have infinite distance between the two. Hello? Yes, sir.
Can you give that to Adolfo tonight?
I sure will. Okay, thank you. Adolfo. Now, if it diverges, that means you don't approach a specific number. In fact, one good rule of thumb is that your sequence is just going to keep getting bigger and bigger. So what's going to happen here? Yeah. What's 17 plus 4? Plus 4. See, if you kept going, those values are just going to keep getting larger and larger. You could say it approaches infinity, but it doesn't approach a specific number. So this one diverges. There we go. This one diverges. Okay. So let's see what we got here. Let's talk about some arithmetic sequences.
Wait, I have a question.
Yes.
So geometric is always converged?
Not always.
Oh,
Because it could be exponential. Like what if you were to have,
2 over 1.
2 to the x? So if x is 1, you'd have 2. Then 2, 4. Then 8. And then you'd have 16. So see there, it's geometric, but see the values are getting larger.
It was just in that specific.
Yes, that was in that specific example. Okay. So a geometric could converge or diverge. An arithmetic sequence could converge or diverge. Okay. All right, so here we got our formulas. Okay, arithmetic sequences have the same differences between the terms. And I'll go ahead and show you that in a minute. We use D to represent the common difference. So 2 formulas on here are my explicit formulas. And then I've got another one on here, 2 of them that are my recursive. So let me go ahead and do this. Let me color code these. So the recursive formulas are these 2 guys right here. The other ones are explicit. Remember, which ones are we going to like better, the recursive or the explicit? Explicit. That will give me the term immediately that I'm looking for. one formula that's going to be really, 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 really useful to you is this guy right here. If you ever want to create an explicit formula, you're going to use that last one. Okay. And what you're going to find is those explicit formulas, if you're just adding some value over and over again, you should get a linear function. It's just going to end up y equals mx plus b, slope-intercept. Okay. And a lot of times I'll probably go ahead and tell you this is an arithmetic sequence, this is a geometric sequence, but if I don't, we definitely want to be able to tell what kind it is. Well, am I adding something over and over again, or am I multiplying by some value over and over again? And at the very top of this page, it's telling you how to figure out what your common difference is if you decide that it's going to be arithmetic. Okay, so if I come back over here very quickly, okay, and I'll go back to that page in just a second. Okay, well, you'll notice if you think it's arithmetic, if you're trying to figure out the value of d, just go ahead and choose two consecutive terms. That means two terms that come right after each other, and just subtract them. So, for example, what is 17 minus 13? 4. 13 minus 9. 4. 9 minus 5. There you go. That's what the top of that next page was talking about. If you could just take two consecutive terms and subtract them, that value that shows up over and over again, that's your common difference. That's how the sequence is going to be generated. Okay. All right, and I think we'll go ahead and stop there today. We'll go ahead and start tomorrow right off with an example. Well, let me answer your question with a question. Are people leaving for lunch?
No.
I'm not. I'm just asking for a friend. Okay. I don't know. Like, are you talking to administrators or teachers? Because I stay in here during lunch. You mean some kids are turning in other kids?
Yeah.
Really? Wow. Wow. That's